So actually, before we get started, any questions that anybody has? Good morning. How the test be conducted? So it should be over Canvas. Again, somebody asked last time how long it's going to be. I think it's going to be an hour and 15. If anything, it might maybe, like 5 minutes longer just to give you time to submit some stuff. But it'll be on Canvas. I don't think we're using the lockdown browser. I'm pretty sure we're not requiring you to have like a webcam for us to record anything. And then, really, for the most part, it's going to be like a mix of multiple choice and essay questions. So you'll probably have to program a few things. I don't think the whole test is written yet, so I've written down all the topics that I think will be on it, and then I wrote some questions, so I wrote down some topics, and I'll probably upload those either later today or maybe over the weekend once I see more of the topics, so that I could give you kind of a complete list. Right. So actually, the other thing I wanted to mention is everybody have access to view the files section on Canvas, or is that like just locked to me? Because I uploaded. Oh, you can view files. Okay, awesome. So hopefully everybody can then. Last night I went and I actually finally found where it stores all of the drawings that we do on this program, because it doesn't actually let me control S or anything, and there's no save option. I guess it only auto saves, and I just didn't know where it was saving it to this whole time, but I kept saying like the document saved thing. But I finally found where all the notes are, so I uploaded all the images. They're under, I guess they're under course image, which probably isn't a helpful name, but if you go to files and then course image, you'll see that there's an examples folder now. I guess I could even drag it over here. So yeah, files, course image, examples, and then I labeled it with the date and then just a thing there. A lot of them won't make sense, out of context, so I guess they're more there if you go back and watch any of the recordings, but there they are in like higher quality, so you don't have to like look at the tiny YouTube screen in lower resolution. The exam is on Wednesday, normal class time. So Wednesday, October 7th, so a week from today. And then, again, we'll do some review on Monday. We may even do a little bit of review today. So I encourage you, if there's anything that you feel like you're struggling on, or if you have questions on, either ask at the end of today, or come prepared for Monday, because really, I guess I'm going to take questions for the first part of class until nobody has any more, and then I guess the rest of it we'll just spend going over things that I think might be useful. Right, so I think I just wanted to tie up some loose things, just looking at some of the questions that other people have written, and then also a couple more things with assignment 5, and maybe just some general problem solving. I realized I said I was going to go over how to do the 2D array stuff, and then I didn't actually do it. I guess I just spaced it. So I wanted to go over that, and I wanted to take a look at the code again. So I guess this is the Skynet one. This isn't the one with the 2D array. I'm just trying to figure out what order I want to go in. I think there's a couple things I wanted to talk about the 2D array, so I'll wait a little bit. When you say we are coding on the test, do you mean in free response boxes? Yeah. You can open like Visual Studio and I guess use it to check if you'd like. Just make sure your syntax is okay. I don't think, at least I personally am not going to like copy and paste everybody's code and throw it in Visual Studio and make sure it compiles in some big project, because it takes long enough for me to grade the test as is. But if you'd like, you can write it in Visual Studio and then copy and paste it over. That's totally okay. But like if you take in 135, they probably had you, assuming you took it in person before all this happened. They probably had you write it out by hand on a test, right? I guess we're trying to still kind of do something like that. Yeah, that sounds about right. Yeah, a lot of the 100, 200 level courses, we usually have like maybe a page of code per thing. I think they're more self-contained in this example, at least with the questions that I've written so far. Is there a limited time where it would stop automatically? Probably. I think it will be after an hour and 15 from summer, because I TA'd an online course for that. I think the way that worked is the test was an hour and 15 minutes, and then it gave you like 15 minutes to upload images if you had like images that you wrote your notes on, like a piece of paper or something. I don't think that would really apply to this. I don't think we're going to ask you to write anything by hand. But yeah, I think it'll cut you off at like an hour and 15. I haven't actually taken an exam on Canvas, so I don't know 100% how it works, but that's what I was told by the students last semester. Or during the summer semester, rather. So, I think we'll start with two things out of here, just so you're familiar with how they work. So, one of them was pretty minor that he wrote here. I've noticed Dr. Fonseca wrote this one. He really likes the syntax. I'm not a huge fan of it, but I just wanted to clear it up in case you saw it. So we have this this constructor for the entity type here that takes a string called name, and there's also a name private variable there. So this might even be a little bit confusing with the syntax looking at it. What this does is not actually call another constructor like you might be used to with the colon and the constructor part. What this does, I guess you could say it calls a constructor, but it's not like a base constructor like you would normally write with this. What this essentially does is this is equivalent to writing this name equals name. It takes the name that is the member and it sets it equal to this part, so it constructs it like that. Just an interesting C++ syntax, I guess. I don't know, they give you the option if you would like to construct or set the like primitive types like this to the argument using that. So maybe it's a little bit more helpful if I called this like n, it would look more like this. So it's the name of the variable and then that. Now you could always write the this name equals name, and I kind of encourage you to, just because I think it's a little more readable. But that's what that line does in the context of his code. But you definitely don't have to use that if you don't like. I just feel like I would mention it, or I should mention it in case anybody's reading over this and a little confused. Right, so the other two things were the array, and then it was pointed out that it appears he uses an iterator, which is a feature that I think C++ 11 up has, and most other languages have this too. Like I know Python and C# do for sure. It's usually called for each, but it's a little bit different looking than a for here. So if I had an example, so you can use this on anything that's like iterable, I guess would be the name. I think there's exactly like a type called iterable, and then it has like some brackets in C#. I don't know if there's a type like that in C++, but something like an array or a vector, something that you would normally go through in a for loop with iteration, hence the name iterable. You can you can write it a little bit different of a way. So if I had something that was a array, so let's just say I had a string array called names, and I'll just say it's for long, and it was like Bobby, Sally, Jimmy, like Susan. I don't know. I'll just throw out some common names. So let's say that's my array of strings. So normally the way you would write this is something like for int I equals 0, I less than names dot size, right? You just you go through the whole array this way, so you go from 0 to the end, and then you go up every time, and then if you wanted to access something, it would be the iterable thing, so an array or a vector, and then you would say name sub I dot whatever you want, right? So there's an alternative to this, and really there's no efficiency that you get as far as I'm concerned from using this syntax. It's really just a convenience thing. So another way I could write this is I could say for, so you give the type name, so you basically do a variable declaration kind of like this. So you could say for string name in names, or I guess in this case it uses a colon. A lot of other languages use the word in, so I'll just say in. For string name in names, oops, that is parenthesis. And then what you can do now is you can access that individual as a name, dot whatever. So what this does is it creates a new variable called name, and it sets it to be everything. So in the top one here, name sub I, as it goes from 0 to size, that is Bobby, then Sally, then Jimmy, then Susan. Same sort of thing here. When we write it this way, it sets name equal to Bobby, and then on the next loop it says name equal to Sally, and then name equal to Jimmy, and then name equal to Susan. So it's maybe a little more readable, and I personally like this for like more complex data types, or if I know I don't necessarily need to keep track of a count. What's the difference of using one colon versus two colons? Oh, so one colon is used for a couple different things. So it's used for this here. It's used for, so I guess it doesn't have like a specific rule. It's not like necessarily a like a clearly defined operator like colon is. So colon is just used for a couple different things. It's used for this thing. It's used for inheriting from the base class with like a constructor, right? You can call the constructor of the base class, or a base class rather, because you could definitely have multiple. The single colon has a variety of uses. I think they just kind of throw it in C++. The colon now, that's a specific operator. So the colon, that is a scope resolution, and you would think there'd be an example of that somewhere here. Yeah. So when you use a colon in C++, that means that it is a member, and specifically, like, I guess you could say a static member of whatever is on the left-hand side. So when you're writing function declarations, right, that just means that this here that I highlighted wrong, this function print gadget belongs to the class IGT. So this here, I'm not writing print gadgets in the context of IGT, so it needs to know where it came from, that's where the scope resolution operator comes in. You tell it the scope that it's from. So in this case, the scope is the IGT class. So for the loop, the name variable is only the part of that loop, however, right? And you use a variable in the loop. Yeah, exactly. So if I try to use name down here, then that's a no-no. Unless it's defined previously. So if I had another one, like even an integer named name for some reason, then that's okay. But it's local to here, so the scope of it is only that for each loop. So it's kind of convenient. I use it a lot for like data types that are more complex, like class types. Yeah, I guess that's all I really have to say about that. It's very convenient. I think the syntax in C++ looks a little strange, but it's very nice. And it's super readable, I think, in languages like Python and C#, because that looks more like... This is the C# one. Python's a little different. The Python one is basically just writing English, and it kind of just works, and it's a little funny. Oh yeah, moving from Python is a hard language to transition from. I think the other way around is not as bad, but Python's kind of loose in the way that it works. So like, I guess this is what I did again over the summer. I'd have like a list of labs, which is the vector equivalent in C#, and then it would just give me every lab in the list of labs. And I think this is pretty readable, because it's almost just a straight up English sentence. So I think it's pretty obvious what that does. Aren't we going to learn? Oh, you can. If you take a class in any sort of machine learning, they're probably going to teach you Python. I mean, you can definitely teach Python to yourself. After this class, I think Python's not very hard if you already know another language, I don't think. I'm just not a huge fan of Python for a couple of reasons. And classes in Python are just kind of... They're not fun to use, in my opinion. Because Python's not a statically typed language, so you don't write like int variable, float variable, so you don't really necessarily know what type of variable you're using at any given moment. They can take on any type that you want. And I don't know. It's a little difficult to write sometimes. At least you're trying to make like a big project. Anyways, I digress. Any other questions on this iterable stuff? It's really not something that you need. It's just kind of a convenience thing. So we have that for part where you can loop over elements. Oh, right. Actually, one last thing with that. He has it written a little bit differently wherever it was. I guess there's a keyword in C++ for this, which there is in C# as well. It does this, so that's not too surprising. It said like for auto. I thought it was in the other file. Must have been this one. Yeah, there it is. So you notice that he instead has, so you have vector gadget list, and then it says for auto I list. So what this does is this will automatically, if you put the word auto and then an ampersand, it will automatically pick the type that belongs there. So in this case, because it's going through this list, which is a vector, it is going to set the auto to gadget for you. So I could have also put auto here in place of string, and then it automatically would have filled in string for me. That might be useful if you just, I guess, don't necessarily know the type, like you're being passed something that's more, freeform. Maybe it's something like an inherited type, where kind of like the that we had, maybe you're just taking in a list of game objects, but maybe it's a specific list of game objects. Like for some reason, I pass in a list of enemies and you just don't know that, but it's passed in like a parameter as a list of game objects, and you want it to be more specific. I suppose you could always do it that way, but I don't think there's a whole lot of advantage to writing auto. I would write the type just because I think it's more readable, but you don't have to. But I guess the other thing to notice here is that, you know, he uses the type I, which is going to be a gadget variable that gets instantiated for every, or not instantiated, but it gets copied over for every single gadget in this list. And so you can access the gadget like you would, so I.name and I.description. Now if you use the auto, it might not actually give you these suggestions if you're used to Visual Studio, where it gives you variable suggestions. If you put auto, it might actually not know the type when it runs it, or I guess it's looking for it, so you might not get these kinds of suggestions. And you might be inclined to have a type error if you put the auto. So I encourage you not to, but you definitely can. Okay, so yeah, let's finally get back to that array thing that I said I was going to talk about and then just totally spaced. So we have a pointer for gadgets. So he's made this gadgets array a 2D array of pointers. So we're going to have a pointer to some pointers, and we need to work with that somehow. So there's the aspect of actually adding things to this array, which I'm just going to go over without the whole pointer thing because we don't really need it. And then there's the actual allocation part of it. So I was not thinking, I guess, the other day, the way we have to allocate this is a little bit counterintuitive, although it will make sense, I think, in terms of implementation. So whereas when you do it normally, like with a static array allocation, you typically write something like int array, and then you give, you know, 2 numbers. If I was to do a 2D array, which is what we want to do here, you might do something like this, and that's totally fine. Now, when we try to do this in a dynamic allocation, so if I was to take gadgets here, which is this 3D pointer, so if I was to try to make this point to a 2D array of pointers, then you might expect something like this to work. So I say new gadget t, and then we give a number, and then we give another number, and it should give me an error. Oh, it didn't. I guess that's no big deal. But I guess it usually works when we put variables in a dynamic allocation as well, right? We were able to dynamically allocate it. Oh, you know, it's because I'm using Visual Studio Code. I think it's not getting me all these errors. Although I'd imagine it would. I'm not sure. So this, I've tried, and I know a student pointed it out. It didn't actually work. And so I wanted to go over the way that they actually want you to allocate something like that with this this pointer array. I'm just going to call it gadget here. So I have gadget pointer gadget. And we want this to be a 2D array of pointers. So the first thing we're going to need to do is allocate. So I guess if we think about the array normally, it would look something like this. It's going to be 3 by 3 in the context of the program. But for the sake of my example, let's just make it 4 by 2 so we can tell the difference between rows and columns. So this is a 2 by 4. Yeah. Yep. So if I was to write it statically, yeah, it would be those numbers like that. And then Right, so this is the way I would normally access it. So this would be like 0, 1. I'm not going to put the little brackets because I don't think it'll fit in the box, but that's what it would be. Oh, sorry, not 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, or not 0. This is row 1, element 0, row 1, element 1, row 1, element 2, row 1, element 3. So that's usually the way we conceptualize it. Rows come first, then columns come next. And I do that just because it looks like a matrix in math, and I think that's... it maybe makes more sense. Plus, this is kind of the way that it's usually written in actual memory, too. They typically write it this way. With the way it's stored, it typically goes like that. So it goes row first, then column. So what we're going to do here is we're going to allocate the rows first, and then we're going to allocate the columns within them. So as far as actually allocating this, I would actually want to first... I should probably close Discord. We're going to first allocate this. So I'm going to allocate a way to point to these. So you notice that everything in a row here is shared. Same thing with a column, but we said we wanted to go row first. So I'm going to say gadgets is equal to a new... I guess I'm just going to go to the next line. A new gadget, which is the... I'm just going to say R for rows. So we'll say this is R and this is C. So what this will do is it will basically create an array of pointers that points to this row, and then this row as well. So nothing is actually allocated there yet, but we've got like pointers to a set of rows each time. And then what we want to do is now allocate the actual space there. So as far as I'm concerned right now, I just have an array of two things like this, and then it's just pointing to nothing right now. So when I write this, I guess I mean null. Or an empty list, I guess you could say as well. But that's not really what it is. So I'm going to need to actually allocate the space in any of these. So something interesting about this is you could actually have different size rows if you really, really wanted to. So I could allocate this one to be 3, and then this one to be 4, and then the next one to be 5, or something like that, which has a variety of uses, so you could totally do that. But we'll just make them all the same here. So I'm going to go through each of these. So I would say something like for int I equals 0, I less than r, I plus plus. And then I would say that the gadgets sub I is equal to a new... I guess I should have made that... I don't even think I wrote that right. What am I doing? Let's put this here. Should be like that, right? Let me move it over. It's supposed to be a gadget pointer. I guess I wasn't really thinking. Gadget pointer. And the reason it's a pointer is because this is a pointer. So there's 3 levels of interaction there. So I'm removing one of them by giving a number to this thing. So for every dimension that I'm adding, I'm going to need to remove one of those levels of pointers for it. So I guess if we think about the final finished array, this level of pointers, this blue one, is pointing to a list of pointers, or rather it's pointing to, array, which is a pointer itself, and then each of those elements in the array is going to be a pointer as well. Okay, so then the next level, if this one has removed one layer of indirections, this one's going to remove another one. So when I go to allocate it, it will be new gadget single pointer, because I'm going to remove another one to allocate, let's just say C for column, like we had there. Make that green. And so now what this will do is it will go and it will allocate, actually a pointer, but it will allocate the column many that we want. So I guess this would be the 0 and the 1 pointer, pointing to two different arrays, and then this part right here is actually pointing to this array of things, and then each of those is pointing to a new array of things. So the idea is to create an array of arrays. So this is the first level of array, and then the second level of array. And then now we can actually access this the normal way that we normally do. So if I wanted to access this element, I would say gadget 0, 0. So I think the allocation is maybe not super intuitive, but once we have that out of the way, you can really just use it like you'd normally use an array. So this element is 0, 0. This element would be like 1, 1. Basically just the same thing that we have up there, right? So you can access it like a normal array, like you're used to. It's just the actual allocation itself might be a little strange. So is this a little more condensed way to make embedded arrays? Yes. Is this better for memory? What is the purpose of having so many pointers? Good question. So it's not better for, well, it has pros and cons. So the pro to it is that it's very flexible in where you allocate things. So I don't necessarily have to have it like a normal array where I just allocate it all together or I allocate it all at once. I can kind of make it a little more flexible in terms of where I'm allocating things and where that gets fit into memory, which is something the system itself, the OS, takes care of. But I have a little bit more flexibility as to where these like individual blocks of memory are stored. It will kind of just put it wherever it can, which is, I guess, a little nice compared to just, throwing down a big block somewhere. For efficiency, it's not that great because it's not done when you do a static array. I believe it's done before runtime, so it's done when the program is actually loaded into memory. It loads the array. Whereas this needs to be loaded at runtime, which means it takes a little bit of overhead, a little bit of extra time to allocate these when you actually write a new statement, versus if I was to just do the normal 2D array allocation that you learned in 135. So there's pros and cons to it. They'll talk more about it in something like 370 and 218 in like technical detail. But there's definitely pros and cons to both of them. I've always wondered the difference using a pointer array and a vector. A vector really is a pointer array, sort of. It's just kind of hidden. At least it should be in implementation, I would imagine. That's the efficient way to do it. Any other questions on this? I'm just going to box this part off. Make a mental note of this one. If anything, that's what you're going to need for assignment 5. I'm still confused about this 3-level pointer. Can you break down what each level points to? Yeah. So this array itself is it's a pointer array. So if I was to do a normal 2D array, it would only be 2 levels, and then I'd remove one from each of those as well. But the way he has this specific array set up, it's going to be a 2D array, so that's where the first 2 levels of pointers come from. That's the 2D part, and then this is the type. Although another way you could interpret this is you could make a three-dimensional array of gadget objects, and that's what pointer pointer was. Yeah, the pointer pointer is the two, well, one's the rows, one's the columns, so it's like dimensions of your array is where each of those are coming into play. So the actual pointers here, the first level is pointing to, so this is pointer 0, I guess. This is the first pointer. It's pointing to an array of pointers. So this is that blue part. It's pointing to R many elements. So it's pointing to an array with R many elements, and that array has pointers that then point to each row. So this one was the column length, and then that there. Column, and then this one was the row. So this is a pointer pointing there, and it's there. And then each of these has a pointer itself in it, which are the actual elements of the array itself. So this is, binoculars, maybe. This is like binoculars here. And then this is maybe like the helicopter, that kind of thing. So by having the first two, you're breaking down, separating the array. Yep. And unfortunately, that's just the way that multi-dimensional, like, dynamic allocation works in really any language. I didn't think it worked that way in C++, but I guess I was wrong about that. I know this is the way that it works in C#. The third is the inside part. Yep. So for every pointer, that's a level, or a potential level, rather, of array that you can have. So these two are the actual dimensions with the way he has it set up. These two are the actual dimensions, and then this part here is the type that's in the array. So this is a 2D array of gadget pointers. Now you could also, again, interpret this as a three-dimensional array if you really wanted to, but with the way he's intending it to be used, it's a 2D array of pointers. You could also make this a one-dimensional array of two-dimensional arrays, or like a one-dimensional array of pointers if you wanted to. There's a bunch of different ways you can interpret this. It just kind of depends on how you're viewing the indirection that's going on. And by indirection, I just mean pointers pointing to pointers, where we don't just directly put something in the memory space like it would make sense to do, maybe intuitively. We kind of split things up. And they will cover this more in detail in 2.18 when they go into like technical stuff about addresses and pointers and all that. This is kind of an overview, at least so that we have some baseline understanding of why this code does what it does, which you'll need for assignment 5. Any other questions regarding that? Oh, do you need some sort of iterator for C? This C right here. This one's a constant. Sorry. So these two are going to be predefined. So these are like the L and the W in that constructor. So these, I'll just say predefined. Whether that's at runtime and then passed into some sort of function, or read from the user, or actually like a real constant, not really known, I guess. But we're going to assume that we know them somehow beforehand. Any other questions on this? I know this image is kind of like a mess now. It's like so much stuff going on. If you look at this later, it's probably just going to be a mess. But the stuff in the yellow, I think, again, just if you take anything away from this, it's that. Okay, so we'll come back to this if anybody has questions. The next thing I wanted to go over was how we can actually deal with a 2D array and inserting things. So as far as the search part, so I think he said he did this as a 2D array just to have you practice like non-linear ways of storing things. There's not really a space efficiency sort of deal with this, and yeah, I don't know. Not a huge fan of it, but you know, we'll go over it at least. There's some, you know, stuff we can at least learn from this. So, not sure if I want to talk about linearization. I guess another way we could interpret that other array, if you didn't want to do it in the way that I just did. Now this won't work in the context of assignment 5s, but I'm just bringing it up anyways, is we could just lay everything out as a flat line. And in fact, this is the way that any memory works in RAM, because RAM is one-dimensional. You know, it just goes straight up. It counts addresses 0 to, you know, how many ever gigabytes of RAM you have, and it throws things in there. So another way I could have done that, where this was, wish the WebEx thing would go away. Yeah, there we go. So if I was to look at this array again, where it's like 0, 0, 0, 1, 0, 2, 0, 3, so on, is I could take that second row and kind of just flatten it out to a straight line. So I could do something where this is like 0, 0, this is 0, 1, this is 0, 2, 0, 3, and then the next one was 1, 0, or sorry, yeah, 1, 0, and then 1, 1, and then 1, 2, and then 1, 3. So we like put this here, and then we just put the other one after it. So this is another way to go about doing it. Now, does anybody know of a way that I could figure out how much space that is? So, okay, assuming this is like 2 by 4, where this is row by column. How many blocks of memory am I going to need? And the answer is kind of just sitting there. I guess I kind of wrote it, but that's fine. It's 8, right? That's 2 times 4. So I could also, let's just make this an integer pointer unlike the other one. Let's say integer pointer, maybe pointer if we were talking about the other one. Integer pointer array equals new int. And in this case it'll be 8, which I could say is the row times the columns. Right, so that's another way we could go about doing it. And then we would have to figure out going the other way though. So now it's a one-dimensional array that we're pretending is a two-dimensional array. So accessing that, maybe we'll talk about it if we have a little bit more time, but that's just another approach to it. I'll let you think about the math if we don't have the time. It's not particularly bad, just we'll have to consider the rows here. So then, yeah, I guess the other thing I wanted to talk about was just actually putting things in there. So let's use the same array yet again, where it's 4 by 2. And so if I was to go in order with the way I would want to fill this up, we typically read left to right and then up to down. So I would go this way. I would say this is the 0th element, first one, second one, third one, 4th, 5th, 6th, 7th. And I think I put an image in the chat for this as well, if you'd like to look at that, kind of pre-drawn. So if I have a, again, 2 by 4 array, and I want to figure out exactly where I'm going to add things. So in this case, he wants you to add in the constructor for the inspector gadget type, I think. We're going to be adding a gadget type to each element. And so what I suggest you do is you just count up with the total number that there are, because we don't really know if it's going to fill the entire array, but we can maybe keep track of a count or something. Is I would say, let's go for int I equals 0, I less than row times column, which we established is how many are in this, right? And then I plus plus. So then the question is, assuming I have the 2D array already, let's just call it R. We'll assume this is predefined, which it should be in the constructor. We'll already have allocated that 2D array the way we did on the first slide here. We want to be able to do something where we say R sub something is equal to element I. Where we're just going to say this is the one from the file. It's not going to look directly like this when you write it, but let's just say in general we want to set the ith thing that we want to set into a 2D array rather than a 1D array. Now, is there any sort of pattern that we can extrapolate from this where we can always figure this part out and that part out? So what I suggest, unless anybody has a suggestion, I'll let you think about it for a second. I'm just going to draw this. If you have something, throw it out. I'm going to just draw this. Oh, that deleted the whole thing. Alright. So what I suggest is we take a look at the number of columns, the number of things we have in a row. So we're consistently going to have 4 here, right? So if I look at these, I'm going to try doing division by 4. Or in other words, division by the column. So what is 0 divided by 4? That would be 0, right? What is... let me write this in a different color. So 0 divided by 4 is 0. 1 divided by 4 would be 0, right? And then 2 divided by 4 would be 0. 3 divided by 4 would be 0. And then 4 divided by 4 would be 1. Is everybody okay with the integer division I'm doing there? Yeah, right. So anything that's less than 4 will be 0. So 4 divided by 4 is just like naturally 1. 5 divided by 4 would be 1. 6 divided by 4 would be 1. And 7 divided by 4 would be 1. Okay, now obviously this isn't the whole division. This is just the like divide part, but it's not like the whole thing that actually happens when we do it. There's always a remainder, right? So what is 0 divided by 4? What's the remainder on that one? 0, right? Yep. And then so 1 divided by 4, that would give us a remainder of 1, right? 2 divided by 4 would give us a remainder of 2. And 3 divided by 4 would give us a remainder of 3. And then 4 divided by 4 would give us a remainder of 0, 1, 2, and 3. So you should hopefully notice with all of these numbers, if I take the column count and I do division, I keep the remainder, I end up getting a pattern. So everything is in common in a column. The number is the same. So this is 1, 0, 1, 2, 3. That's the column number. And then the actual division part, that is 0 and 1. That's the actual division part. So this is... Oh, whoops. That's not right. We'll just say divided by. And then this one is the remainder, which is like the modulus operator, right? So if you notice, this kind of lines up these numbers here with the actual indices that make sense when we access these earlier. So 0, 0, 0, 1, 0, 2, 0, 3, 1, 0. These are really just the same numbers, right? The first number is the division part, and the second number is the modulus, or the remainder. So one way I could access these is I can actually just take, so for the first part here, the row number is the red, so I think I have red, oh, there we go. So that will be I, whatever the number is that we're doing. So I goes from 0 to 7, it will be all those numbers in the array, divided by 4. And then the second part here, for each of these, is going to be the remainder. 4. So I said 4, but let's change that to column. So in this case, 4 was the column number, right? And again, we know these in advance, the column number. So the fact that we know it will allow us to actually use it there. And there we go. We've taken a linear thing and we've put it into a two-dimensional array. So you'll want to do this on assignment 5 as far as the insertion thing where you're reading from the file. You'll want to take each element. I suggest having a counter like this, maybe outside of the context of the for loop, because you're going to need to have like a while not end of file or something. And then having the two indices be the division and the modulus. And then it'll kind of just fill it in the way it needs to. Are there any questions as to how I got any of that or why it works? I apologize for the sloppy handwriting. There's probably a better version on Discord. Is there an alternate way of doing a nested for loop? Yes. If we have time, I'll talk about it. Yeah, good question. That's actually what I was going to do as far as accessing this part. Yeah, we could do that. But I guess that's assuming it's linearized. Oh, or is this, sorry, I misread that. Is this an alternate way? Yeah, this is an alternate way that you could do a nested for loop, I suppose. Yeah, that'd be fine. As long as it's some sort of two-dimensional array. Yeah, that's okay. I mean, I don't think this is a good idea. I would rather you do it as a nested for loop because A, it's more readable, but B, every single loop I actually have to do this calculation of division and remainder, and that takes computation time, whereas the other one is just setting something equal to something. So don't do it this way if you don't have to, but it's there, I guess, as a tool. So that for loop should be outside of the end of file when we are reading in, or rather, I guess what I mean is you'll probably want to do something like while, so int I equals 0 while not, I'm just going to write this as like pseudocode, while not end of file. Do whatever, do this stuff. And then I++. So don't put a for loop. Just declare I outside of it and use while, because we want to loop while it's not at the end of the file. We're not going to know this amount in advance if we're actually reading a file, because you can't really know how many lines are in a file unless you have header information, right? Like if I give you a 10-line file, you can't know it's 10 until you finish reading it. So this is assuming you already know the amount that you're going to read in advance, so unfortunately that doesn't really work here. And actually, as a result, you might have to keep account of the gadgets in the actual program. It might at least be good practice to just store a count of them, even though he doesn't have it, because you might get a case where you only read 5 things, and then you'll store there, and there, and then these 3 are uninitialized data, so you don't actually want to access it. So you don't want to go all the way to row times column through the whole array. I guess would be a bit of a issue with this. But you could really solve that in the same sort of way that you would have solved the like finding visitors problem from assignment 4. And then we just apply this extra step on top of it. Any other questions on that? Okay, so while we're here, I guess we'll talk about 2 more things. One of them I'm not going to spend a whole lot of time on. I've just noticed a lot of students have been having trouble with it, so I figured I should go over it one more time just because it's super important, and I wouldn't be surprised if somebody writes a question about it for the test. So, I mean, it's shown up at least twice in the assignments. Let's just say I have an array of things. We'll say integers for the sake of simplicity here, and we'll say this is like 7, 5, 0, 9. So let's say I want to do a check to see, given some integer x, is x in the array? Let's say that's the array. Then what I need to do is I need to search through the whole thing, right? So if you're familiar with logic, we have like 2 cases here. So there's the case where we find it, which would be that there is some x for which x is in the array. If you're used to logic, and if you're not, this I guess isn't a big deal. We can still kind of explain it without it. But this is really what we're looking for, right? If we're finding something, we want to prove that there exists an x that's in the array. Now, for those of you who have taken a logic course or discrete 1 or something like that, what's the opposite of this? So if I was to throw a negation in front of this, do you know what that would be? Yeah, right? So when you use a negation on something, it flips the quantifier. So existential, which is just like there exists one, becomes an all. So the opposite of this would be for all. And then we like kind of permeate, I don't remember the exact word they use, like move the negation across the quantifier, and then it becomes a thing here. So if I was to use a negation on that, it would be not an element, right? So I would just put that there. So whereas if I find it, that means there exists an element such that it's in the array. Then the opposite case is for all of them, x is not in the array. And so the reason I mention this is because we have 2 cases here. When we're doing the for loop that actually searches through this, if we find 1, which is what existential quantifier means, if we find 1, we're done. But if we're looking for the case where nothing is in it, then if we haven't found all of them, if we go across all of them, that's the only time we can ever know that we haven't found it. So I just wanted to write this code out one more time because I've gotten a lot of questions from students about it, and I think it's very important that you know this. So the way that we would write code for this is we would say, well, we want some sort of value to be figured out by this, whether it's find or not find. So these in themselves are Boolean values, right? Find and not find are the Boolean values returned by this logical expression. I apologize if I'm going a little too math heavy here, but I think hopefully if you understand this syntax, then maybe it might make a little more sense. And so what I'm going to do is I'm going to set this one as the default case. I'm going to say false. This guy be that. And so what we want to do is we want to go through the array, obviously, right? So we need to do a linear search and go from 0 to the end. So I'm not going to write out the whole thing. Let's just say for I 0 to end. So I assume you all know how to write that. Now, if we look at this case, This is if there exists one. In other words, if we check any single one and we find that it works, then we know true, or we know that found is true. So there's a more efficient way to do this, but we'll just say if r sub I equals thing. Well, actually, I guess I wrote x here, right? So we could just use x. If r sub I equals x, then we know that the statement is true, right? This would be the existential case. We found a single example, which is what if checks for, right? It checks a single case if we write that expression there. So this would be found equals true. And then we would break. And again, there's a better way to do this. And ask me if you're curious later. But there's that. Oh, two. Let's just say, maybe it would make more sense for me to write this. This isn't real C++. This is just me writing pseudocode. So this won't actually compile. This is just me being lazy. So this just goes through the array. I guess that's what that's supposed to mean. Right, so this would be the existential. If we found one, if there existed a single thing in the array, then we know that we have the true case, where x is in the array. Versus the negation, which is when we don't find it. So if we find it versus if we don't find it, then that would mean we had to go through all things, right? And the point at which I know I've gone through all things is right here. Which is why I kind of set this as false. If you notice here, it will never set it to true if we've gone through the whole thing and never found anything. In other words, if we've gone through all of the things and we didn't find a single instance that matched it, then we know that that's going to be false. So this is that all part, and this is there's one part. And then you can do something down here that checks, if found. Dot, 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 do something. And then else. Well, I guess I don't really need to check there. Yeah. There we go. Do something. Right. So the idea, there's two ideas here. One, think about it kind of logically with those quantifiers. I'm looking for exactly one case or more, or I need to check all of them to not be that, is the other case, the opposite, if you will, of it. So do the search first, and then handle it afterwards. Because I think some things that maybe people are getting tripped on is they're trying to do both at the same time, and you should kind of break your code into individual parts that kind of do like black box kind of, they do something and then output a result. So in this case, this does a search and it returns whether the search was successful or not in the form of found, that boolean. So you should do this kind of split up and work with it from there. But all that makes sense. I really just wanted to review it because I noticed I was getting a lot of questions about it. And I'm sure it'll pop up again because this is something that shows up a lot. Maybe I'll just write this for later. So, okay. So let's see any questions on that. Oh, that's the wrong button. Whoops. Okay, so I think the last thing we'll talk about, unless I really have a lot of time, is let's just talk about how I would do this business is here. So we had that array where it was row by column, 2 by 4, and then this was like 0, 0, 0, 1, 0, 2, 0, 3, and then this was 0, 0, 1, 0, 1, 1, 1, 2, 1, 3. And so what we were saying is we want to maybe take this part and then take that part, and if we had more, we would just keep taking each individual row and then kind of like glue them together end to end. So I wanted to have the whole first row 0, 0, 0, 1, 0, 2, 0, 3 first. And then I glue the next one onto it. So 1, 0, 1, 1, 1, 2, pretend 1, 3 is there. And then we do row 1 there. And so we could keep going. So if I was to linearize this now, this is element 0, 1, 2, 3, 4, 5, and 6. So I'm assuming that I have some sort of, again, I'll just say integer array that is just a pointer here. We'll call it array, and I've allocated it all in a straight line rather than in 2 dimensions, because perhaps I think that's a little bit easier than doing those whole allocating and then doing an array, or doing like more array allocations in the thing and in a for loop, and then kind of having all these layers of indirection. So I could instead, we said, just allocate it all in one big block that's row by column. So this one again was row and that one's column. And now we want to access it. So we've done the allocation. I want to be able to so let's just say int, we'll say it returns that. We want to be able to access this array. And we'll say it's global, I suppose, where we have the int, we'll say I and int j. And this will get r sub ij, basically treating it like it was a 2D array, even though it's in a straight line. Alright. So we might be able to use something similar to what we did for to going backwards, right? Which was to divide and take a modulus. Does anybody have any suggestions as to how I can take these two numbers maybe and figure out exactly where they were? Assuming we have R and C and R. So I guess one question would be, how do I get past a row? So if I was to ask you to get row sub 1 or row 1, anything in row 1, what's the bare minimum number that's going to be? It would probably help if I scroll back up. So it looks like it's going to be 4, right? This one kind of starts at 0. If I was to throw in a third row, it would start at 8, right? Is there anything you can think of that 0, 4, and 8 are related to in terms of the row or the column? Or is there any sort of pattern you notice? I guess this would be 2, 0, if that helps. Yeah, you got it. So it would be I times, or actually, you're on the right track, sorry. Not I times 2, but you're on the right track. 1 plus 1. Not quite. You were closer with the multiplication. Oh, I think you actually got it. I times 4 plus j. Yes. Good job, actually. Yeah, so does everybody see why that is? So I'm going to say I times, you said 4, but I'm going to say c just to keep it generic. But yeah, you're right, it's 4 in this case. Plus j. And that's exactly it. So we'll just say that will return, let's put ret or that. Yeah. So what was just said is, right, so you'll notice that each of these, 0, 4, 8, that's where each row begins in our linear version, right? So row 0 goes from 0 to 3, row 1 goes from 4 to 7, and row 3 goes from 8 to 11. Should. So each of these is starting on 0, 4, 8. The next one will start on 12. So they're starting on multiples of 4, which is the column number. So what I can do is I can actually, so this here, this first number, that's 0 times 4. This one is 1 times 4, and this one is 2 times 4. And this was row 0, row 1, and row 2. So what we can do is we can take the row number, so let's say this is I and this is j. We can take the row number and we can multiply it by 4, because if we think about that, that's just how many blocks of 4 we're skipping over, right? So I could take I times how many ever groups of 4 that I need to actually go over. And then I can simply take the remainder, which is the extra part here, that part if you will, which is the column number, and add together. And so I guess another way to justify this is we were saying that each of these like pairs, right? This was the division part and this was the remainder. And if you wanted a more math way of doing it, then the index here, let's just say if I have r sub k is equal to r sub I, ij, where this is, these are the same array, but this is the 2D version and this is the 1D version. It's linearized. Then we want to write k in terms of I and j, and we said earlier that something like k divided by the column number is equal to, I think I did it blue first, so it was like I remainder j, right? Does this step first, I guess, make sense? This is just the statement that we had earlier going the opposite way. We said if we wanted to map these from a 2D to a linear kind of way, like this, then we can take the division part and the modulus part. So we could say that k divided by the number of columns is I remainder j. And if you are familiar with the way that modulus works, then this means that there exists an integer such that k is I times the number that we're divided by, times c, plus j. So we can use one of those math proofs, if you've seen this before, to actually generate it without having to use the picture as well, if we wanted to prove it that works. But yeah, good job. That's exactly right. That would be it. And then we kind of have like the more gut feeling justification up here, that it's just skipping over blocks of 4, so we can kind of multiply by it every single time, and then add the offset, which is the column number. So if you notice, like the column, that gets reset after every single row. You get 0, 1, 2, 3, and then starts over 0, 1, 2, 3. Great. So I guess I'm a little over time, but if you have to go, by all means, go. If not, if you have any questions on this, feel free to let me know. Or if you have questions on anything else, let me know too. Monday is review, and then Wednesday we'll take the actual exam on Canvas. All right. If you have any questions, feel free to ask. If not, I guess I will see you next Monday.